One of the things that microbiologists are sometimes interested in finding out is the number of bacteria there are in a particular sample. So for example, if you have a sewage sample or a food sample and you want to know how much bacteria there are in that sample, one of the ways of doing that is just to simply take the sample and to plate it. The problem comes in though when the sample that you're testing has a lot of bacteria in it. Because if that's the case, when you plate it, what you would end up with is just a lawn of bacteria on your plate. In other words, you just get just a layer of bacteria covering the entire plate. And when you have that, it would be impossible then to count colonies on that plate, which means that it would be impossible to come up with a number of bacteria there were in the original sample. You just know that there was a lot, but you couldn't come up with a specific number. So if you want to come up with a specific number, what you'd have to do is to first dilute the sample and then plate it, because that way you then get a plate that has a countable number of colonies on it. One way of diluting a particular sample is by doing something called a 100-fold serial dilution. And so here's one way of setting that up. All right, so if you want to dilute this, well, first of all, how about if we name this? So it turns out that the sample that you have, if it's undiluted, this will make sense. It's considered to be the 100% concentration of your sample. There are different ways of saying 100% concentration though. So that's the same thing as saying that this sample has a dilution factor of 1. And another way of saying 1 is 10 to the 0. Right, so all of this here just means that this is your 100% concentrated undiluted sample. One way to dilute this is to take a volume out of your original sample. For example, 1/10 of a milliliter. And by the way, 1/10 of a milliliter, that's the same thing as 100 microliters. And then putting that volume of your sample into a test tube of water that has, or into a test tube that has 9.9 milliliters of water in it. So by doing this, you then dilute this original sample. The question though is exactly how dilute is this compared to the original sample? In other words, exactly what is the dilution factor of this test tube? The way you can figure this out is by using a little equation that goes something like this. To figure out the dilution factor, you could take the volume that you placed in the tube divided by the total volume in that tube, and then you multiply the whole thing by the dilution factor of the transferred solution. So plugging numbers then into this equation to figure out the dilution factor of this sample, here's what it would look like. Right, so in this example, that would equal, well, the volume that you placed in this tube, we're telling you, was 1/10 of a mil. Right? That's how much we put in there. So it would be 1/10 of a mil divided by the total volume in this tube. Well, we're telling you that there's 9.9 mils of water in there, so that's some of the volume. To that 9.9 mils, you added 1/10 of a mil. Right, so you added 1/10 of a mil to that. So this then would be the total volume of liquid in this tube. It says here then that you multiply that whole fraction by the dilution factor of the transferred solution. Here's the solution that we transferred into that tube. Its dilution factor is 1. Right, so you multiply by 1. And so if you solve this whole thing, you get 1/10 of a mil over 10 milliliters. Typically, people don't like to have fractions in their decimals, and so one way to eliminate this fraction is to multiply the top and the bottom by 10. And when you do that, you get 1 over 100. So this tells you that the sample in this tube is 1/100th the concentration of the sample, of the original sample. In other words, the original sample is 100 times more concentrated than what you have here. Right, so that's what dilution factor tells you. It turns out that there's different ways of saying 1 over 100. So that's the same as saying 1 over 10 squared, which is the same thing as saying 10 to the minus 2. So all three of these bolded expressions here are the same way of saying that this is 1/100th the concentration of the original sample. Right, so let's go ahead and jot that down. This has a dilution factor of 1/100. Typically, if you have a really concentrated sample, a 1 to 100 dilution would not be dilute enough to give you a plate that has a nice manageable number of colonies on it. So when you do dilution plating, typically you carry out the dilutions further than 1 to 100. And so one way to do that is just to do what we did here, except now to this tube. So you could take 1/10 of a mil out of this tube, which equals 100 microliters, place it into another test tube that has 9.9 milliliters of water in there. And so now this is even more dilute than what you made here. But the question is exactly how dilute then is this sample compared to the original sample? In other words, what's this sample's dilution factor? Again, you can always figure that out by plugging numbers into this little equation here that we just showed you. And so in this particular example, here's the numbers you would get. So the volume you placed in this tube was 1/10 of a mil, so that's what you would have here, divided by the total volume in that tube. Well, the total volume in that tube is the 9.9 milliliters of water that was in there to begin with, times the plus the 1/10 of a milliliter that you just put in there. Right, so this is the total amount of liquid then in this tube. And it says that you multiply that whole thing by the dilution factor of the transferred solution. All right, here's the solution that you transferred into this tube. Its dilution factor is 1/100. All right, so that's the dilution factor of the transferred solution. So if you solve for all of this, that'll then give you the dilution factor of this sample. All right, so here's how you do it. That all equals, well, everything in the yellow here is 1/100 times this 1/100. That'll give you 1/10,000. And basically what this tells you is that this sample is 1/10,000th the concentration of the original. In other words, the original is 10,000 times more concentrated than this sample. Again, there's different ways of saying 1 to 10,000 dilution. That's the same thing as 1/10 to the 4, which is the same thing as 10 to the minus 4. Right, so again, all of this is the same way of saying what the dilution factor of this sample is. It's 1 to 10,000. So then after you have your dilutions made, then these are what you end up plating. And the purpose of plating all of these is then to, at the end, look at which plate gives you a nice, manageable, countable number of colonies that you can then use to figure out the concentration of bacteria there were in your original sample. So to plate these dilutions then, what you're going to be asked to do is to take volumes out of each one of these dilutions that you prepared and plate them. And it turns out that you're going to be asked to take 1 milliliters out of each one of your dilutions and plate it. And you're also going to be asked to take 1/10 of a milliliter out of each one of your dilutions and plate it. And so when you end up incubating all of these plates, which you should expect to see then at the end of the incubation period, is something like this. Well, how about if you mention this, that you're actually going to be asked to label all of your plates with these particular numbers before you incubate them. And we'll talk about what these numbers mean in a minute. But after you plate your dilutions and after you incubate them, you should expect to see something like this, where, and this should make sense, that the most concentrated dilution will give you the most number of bacteria on the plate, and then it just kind of peters out as you get towards the more dilute samples. And so once you see this, then you can use these results in order to figure out the concentration of bacteria in the original sample. And hypothetically, because each colony on the plate came from a single bacterium, you can figure out then the number of bacterial cells there were in the original sample.